All right, let's go ahead and get started. Good morning, everyone. Thank you very much for joining us for our session today. My name is Kimberly, and I've been with AWS 5 years now, and I work in SageMaker product marketing, and I'm going to lead off the presentation. Joining me is my colleague from the tech side, Dennis. He has a PhD, and he'll be showing you how to build cool things in notebooks. And we are very honored to have a vice president with Thomson Reuters who's responsible for machine learning, artificial intelligence, and BI, who will share her story about how her team uses SageMaker. So I want to dive in really quickly. I'll spend just a few minutes setting the stage before we dive right into our demos for today. I'm going to go over some key capabilities of Amazon SageMaker. Then I'm going to hand it over to Dennis, who's going to deep dive into how data scientists can use SageMaker Studio to build, train, and deploy their machine learning models. Then I'll show you the easier way to do it with our no-code ML solution called SageMaker Canvas. Then Maria will join us and talk about how her team has standardized on SageMaker and her journey using SageMaker over the years. So if you've been coming to reInvent for a while, you may remember we first launched SageMaker in 2017. And we started with a fully managed notebook in the cloud. And then over time, we built over 25 new services that are part of SageMaker. And since launch, we've launched 250 new capabilities. When we started in 2017, the focus was really on managed infrastructure and notebooks, hosting and training in the cloud. And then in 2018, we moved to providing support for unstructured data through SageMaker Ground Truth. And SageMaker Ground Truth gives you everything you need to label data, prepare it on the unstructured side for things like computer vision, natural language processing, and more complex machine learning tasks. But between 2019 and 2020, we built 25 new capabilities focused on purpose-built capabilities for machine learning. So the world's first IDE, pipelines, model monitoring, debugging. And the goal here really was to bring the same kind of purpose-built tools that we have in the software development space into machine learning. So it's been quite a journey. And then last year, we launched our no-code solution called Canvas. So we're going to talk about all these capabilities in depth, but I just wanted to put the timeline out here to kind of set the stage for how rapidly we've been innovating. And SageMaker has really helped customers scale with machine learning. So today, customers are labeling millions of tasks per day. They're training millions of models, running billions of predictions every month, and training models with billions of parameters. So these are really large models that do things like natural language processing and computer vision. So just wanted to give a sense of the scale that we've seen from the growth of SageMaker. So one of the things about SageMaker that I just wanted to call out is though we started as fully managed Jupyter notebooks in the cloud, we've expanded so that we have purpose-built tools no matter what your job is. So if you're like Dennis, PhD, computer scientist, you have the tools you need. If you're like me on the business side, there's low-code solutions. And for ops folks in the room, we have a robust set for ML ops engineers. And the goal of the presentation today is to show you a demo and show you how each of these capabilities can be used together. So the goal with SageMaker is to give you the solutions and tools you need no matter where you are in your journey. It's a modular service. You can pick and choose the capabilities that best make sense for your use case, and you can team up and collaborate with your colleagues. I just wanted to take a minute to set the stage because this brand has grown so much over time. So just wanted to kind of level set on what we mean by the SageMaker brand. And under this, there's about 25 services. So what we're going to do first is focus on the data science experience. And I'll just highlight very quickly the key capabilities for data scientists. And I'll start with model building. Here we have hosted Jupyter notebooks in the cloud that are available using fully managed infrastructure. And you can take advantage of AWS custom-built infrastructure like Trainium and Inferentia, or use infrastructure from our third-party partners. We have built-in algorithms available to you so you can quickly get up and running fast. Some examples would be deep AR, k-means clustering, linear learner, k-nearest neighbor. There's many, many built-in algorithms to help you move quickly, and we're constantly innovating on that. We also have something called SageMaker Jumpstart, and we also have sessions on all of these topics that go into much more depth as well throughout the conference. And Jumpstart provides pre-built models, algorithms, solutions complete with CloudFormation templates, developer resources guide, so you can get started very quickly with your machine learning projects. And we also added AutoML called Autopilot, and that's very easy to build models on tabular data. You bring your tabular data in, specify the target column you want to predict, and Autopilot automatically generates a bunch of models. It creates a leaderboard. You can look at things like performance and latency and pick the best model for your use case. So all of this is designed really to help data scientists be much more productive. And also, of course, we have optimizations for all the deep learning frameworks like TensorFlow and PyTorch, and Hugging Face, and many more. So that's a quick overview on build capabilities, which Dennis will show you in a minute. And then we also have a bunch of capabilities around model training. And the idea with model training is to make it as fast and cheap as we possibly can. We've got a lot of built-in capabilities that make best use of the infrastructure. For example, you could use managed spot training. We have distributed training, which allows you to perform data and model parallelism. We also take advantage of optimizing the GPUs so that you can, with our training compiler, so it runs much faster. So debuggers also available, so lots of tools so that you can get fast performance and cheap performance in training. We also, when your training jobs are running, there's capabilities that allow you to check your instant usage out, so you can make sure you're continuously optimizing costs. And then finally, for deployment, over 70 different instance types to choose from. I mentioned Inferentia, which is our custom-built chip that helps you deploy your models. There's also different options, asynchronous and batch inference, depending on the latency requirements of your model. If you need very, very fast latency, or for longer running jobs like computer vision, you have the flexibility and the option to deploy the inference type that's best for your use case. We also have things like pipelines and model monitors, so you can monitor your models in production. And we have an instance recommender, so it can be overwhelming to look at all the different instance types to know what's best for you. So last year, we also launched an instance recommender. So that was a very, very quick whirlwind tour, intentionally done because we want to get you into the demo and show you how this works inside SageMaker Studio. So all of these capabilities across build, train, and deploy are made available to you in the world's first IDE for machine learning called SageMaker Studio. And with that, I would like to welcome Dennis to the stage to take you through that demo.
Thank you, Kim. So today, for this demo, I'm going to take you from kind of an idea to a working prototype with Amazon SageMaker Studio. We're going to train a machine learning model to detect bees in images, like this one. So we need to not only identify that there is a bee in the image, but of course also the bounding box of where the bee is. And now, why bees, you might ask? Honeybee is the most important pollinator worldwide, and honeybee colonies are facing lots of problems, from parasites to diseases and colony collapse. And in a recent study in US, since the 70s, the lifespan of worker bee decreased from 34 days to 17 days. So all these problems with honeybees, and these exist both with breeding colonies and wild pollinators, affect the agricultural production. Some estimates say maybe 8% decrease in production can result from these issues. So we can put cameras in certain locations, right, and take photos, detect the presence of bees, and also perhaps even count the numbers of bees to estimate the overall kind of health of the colonies. So we're going to take a training data set from iNaturalist, which maintains a website and a mobile phone application and brings together amateur naturalists with specialists to help identify species of plants and animals in pictures. So you take a photo with the app, you upload it, and you share it with a community that help you actually arrive at a scientific identification. So for this project, we've downloaded 500 images of bees, so each image is guaranteed to contain a honeybee. It's already been identified. So not a bumblebee, not a wasp, not a hornet. There is a bee, or at least one bee in each image. And these images have been uploaded by users under the Creative Commons CC0 license, so they're available for everybody to use. Okay, so we're going to build an object detection model, which means we need to know the location of bees, right? Where are the bounding boxes? And what are we going to do for that? Well, luckily we have Amazon SageMaker Ground Truth, which allowed us to annotate and label all those images. And in fact, there's a way to rely on a large pool of 500,000 labelers, human labelers, and SageMaker Ground Truth allows you to label data sets both easily and economically. It supports currently a wide variety of different labeling workflows, so ranging from simple image detection or image identification, all the way down to LiDAR, 3D, point cloud, which are very complex workflows. And for this project, we've used the top left a workflow of bounding boxes around the bees. And in fact, to label 500 images, it cost us only $200, actually less than that, accounting that for every single image being labeled by 3 people for increased accuracy. So just to give you a sense. Cool. So we're now ready to look at the SageMaker Studio, where we'll train and deploy our model. Now, what you see on screen is the SageMaker Studio interface with the file browser on the left and the bee detector notebook opened on the right. Let's take a moment to explore the images subfolder. This is the one that actually contains all the 500 images locally in the SageMaker Studio instance. We can click on the individual images, examine them, see what they look like. And these are local, but we've also uploaded them to S3 already prior to labeling. And remember, labeling has already been done. And so with that, we can also see an output manifest file, which is the augmented manifest containing the results of labeling of each one of those 500 images. And we're going to look at that manifest file shortly. You also see the test subfolder that contains test images set aside, just so we can evaluate the performance of our model at the end. All right, so we really have in this notebook 3 steps. First, we're going to review the labeled data set. Then we're going to configure and train the machine learning model. And finally, deploy it and evaluate its performance. So this first cell actually loads the first line of the manifest file that we just mentioned. And it's a JSON line file. Each line corresponds to a labeled image. And we see that in that JSON, there is the location in S3 of the image. There is also the name of the labeling job called bees 500. And you see the size of the image down below, and under annotations, the results of the labeling, which are the coordinates of the bounding box that was obtained. Now, there is an easier way to actually review the results of the manifest in this case than reading JSON, and that's what we're going to do next. So this function actually takes the bounding box and overlays it over the image. And then the next one simply parses the manifest file line by line and applies that bounding box that is in there. And here are the results. You see images with bees, with red bounding boxes around them. These are just the first 10 out of the 500. This one is worth pausing on. We never said there's just one bee, right? Somebody actually spent the time labeling every single one bee in that image, so that's a lot of work. All right. Moving on to the next step, which is training. So we usually have to have both a training data set and a validation data set, because as we're training, we are going to evaluate the progress of training with the validation data set. So we're going to have to take the 500 images and split them. And I've split them into 400 for training and 100 for validation. So we're just going to take that manifest, randomize, and set aside 400 in one way and 100 in the other file, and that's what you see down below here. We've created those local files, and now we need to upload them to S3. We just need to upload the manifest. Remember, the actual images are already in S3. We just need to point them from those manifest files. Okay, so now we're ready to configure and kick off the training job. So we're going to use the object detection built-in algorithm, and therefore I select object detection and fetch the corresponding container image. And then I need to create a SageMaker estimator. And there I pass in the training image, the execution role, the cluster. Well, in this case, it's just one instance. It's a small data set, really. So I select the P3 2x large, which is an NVIDIA Tesla V100 GPU. And we additionally specify the pipe mode, which means that instead of loading the full data set to the GPU instance first before starting training, we're going to stream the images one by one as the training progresses. And finally, I need to specify the location in S3 where the images go, or the results of the training goes, the model, and the SageMaker session, as usual. And next, we're going to configure the hyperparameters for this built-in algorithm. So we're going to select a ResNet50 neural network topology for this. Now, this algorithm supports two, ResNet50 and VGG16. Both are really well-known topologies for these kinds of tasks, well understood. Now, because I only have 400 images for training, it's a small set, I need to use a pre-trained machine learning model. That's why I say 1, which means that I'm going to start with a neural network that's already been pre-trained on millions of images, though none of them are likely to contain honeybees, right? And next, I select the number of classes, which is 1. I only have bees here. The mini batch size, 1, which seems to be working well for this algorithm. And the shape of the image, that's because most images are 500 pixels along one dimension, so we're going to resize them into 500 by 500 boxes. And finally, I specify the stopping condition. So we're going to train for minimum of 30 epochs. And as soon as the key kind of accuracy indicator starts dropping by more than 5%, we're going to stop training and call it done. And then finally, I also supply the training and validation kind of channels to indicate where that data actually resides. Okay. So now we're ready to execute and call in training with one line of code we call fit. I supply the additional attribute of weight equals false, which means we're not going to block the notebook while the training is going in a separate machine. Instead, I can just use a few lines to test whether the training has been completed. Well, the training has already been done. It takes some time. And in fact, we can go into a separate tab here to look at the SageMaker console, and the results of training, we see 1,300 seconds our training took. Now, at about $3.83 per hour for that machine, that training cost me $1.45. So we can also look at some additional metrics here, and the key metric for us is called mean average precision, or MAP. And you see that it kind of reached a plateau in here, validation MAP, and that's when we've stopped training. And now we're ready to deploy that model. So switching back to the notebook, we're moving on to the final step. So just like training, we could do deployment in one line of code. I also say weight equals false to not block. I select a small instance because for inference here, I don't need a beefy machine. And it's going to take a couple of minutes to actually perform the deployment. And then once I'm done, we're going to evaluate the model. And here are the 10 images that you've seen earlier that are just printed locally in the notebook. And now the next function simply will take the results of the predictions of the SageMaker endpoint and turn them into a nice bounding box. And finally, this next cell is actually the one that's defining a function that calls the SageMaker endpoint, turning the image into a payload of bytes. And the little for loop down below simply calls it 10 times for each of the images. And in addition to that, we want to display a certain number of bounding boxes because you see the object detection model returns more than one. And we could pick the confidence level and how many of these bounding boxes we want to display to see the results. So here we picked 3 and the confidence interval of 0.2. And now we're ready to actually examine the results, the stuff that we've been waiting for. So here's a well-identified B. Not every image actually works well at the confidence interval, so there are some misses. Here's another B. Here we only ask for 3, so we see 3 Bs. And, well, that's another miss over there. This one is a bit funny because you see a little bit of a flower petal arrangement does look like the wings of an insect, and it sees that there's an insect there, even though we know there's no bee there. But it's kind of a curious thing to note. All right, well, we've done this with just 400 images. Imagine what we could do with many more training data samples in terms of kind of accuracy that we can get. And as usual, at the end, we want to do some kind of cleanup, like turn off the endpoint that we're not going to use. Anyways, that completes my demo here. So thank you, and back to you, Kim.
All right, thank you very much, Dennis. Dennis showed us the hard way to build models in SageMaker, although it's quite easy for data scientists. But for people like me who don't code every day for my day-to-day job, I am a business analyst, we have SageMaker Canvas. So for finance, operations, marketing teams who want to be able to make ML predictions as a part of their day-to-day job, they can use SageMaker Canvas. Canvas allows you to bring in data sets locally from your machine. You can drag and drop Excel files, CSV files. You can also pull in data from Amazon sources like Redshift, S3, or even third-party data sources like Snowflake. And then Canvas gives you the option to do a quick model build or a standard model build. I'm going to show you how to do the quick model build in this demo. The standard model build takes a bit longer, but the advantage is all the data and the code that is used to generate the models is fully available inside SageMaker Studio, so business analysts and data scientists can collaborate better across teams. So what I'm going to show in this demo, I'm going to take on the role of a public safety and health officer, and I want to predict survivability of cancer 5 years after diagnosis. So the data set that I'm going to use for this is called SEER. It's an open source data set. Anyone can access the data. It's associated with the US government. And there was a study done in Kentucky for colorectal cancer survivability. The study was run from 2000 to 2017, and it looked at survival rates 5 years after diagnosis. This is a very prevalent cancer. The American Cancer Society estimated that this year about 150,000 people will be impacted. So it's a timely analysis. And by looking at the data, I'm going to look both at the data about the patient, such as their age, and also information about the diagnosis, such as the summary stage and when the diagnosis happened, to be able to make that prediction. All right, so let's dive in. I went in and created a Canvas account, and the first step that we're going to do here is to identify the data that we want to use. We probably all spend a lot of time working with data in our day-to-day jobs, and in Canvas, it's no different. And Canvas gives you helpful information about the data sets, like the source, the columns and rows, when it was created, other things. So we could use any of these data sets and play around with Canvas, but I'm going to call out the import function here. Just click on the import, and I'm going to pull in that SEER data set. As I mentioned, you can pull in data from S3, Redshift, or Snowflake, but I'm just going to go ahead. You can also drag and drop, but I'm also going to go ahead and just pull this in from the local machine. Obviously, depending on the size of the data, it could take a few minutes or a little bit longer, but we can see here is the data set from the Kentucky study. As the data is loading, I just wanted to point out there's a handy feature called preview. So before you actually do the import, you can look at the data to make sure that the columns are correct in that you would expect from the data set, and that it will be helpful for your prediction. So in this case, we see things like gender, age of diagnosis, marital status, cancer grade, all of these things, they're probably very relevant for us, so this data set looks good. So I'm gonna go ahead and import it. It takes just a few minutes here. And then once the data is imported, I select it and very quickly just click Build My Model. So for those of us on the business side, this is quite convenient. Go ahead and click Create Model. I'm just gonna call it my model in this case. Okay, so after the model is created, Canvas provides a really nice view of all the data and does a lot of undifferentiated heavy lifting under the covers to help you be productive with your data. So let's look at some of the columns here. We can see the data type, missing values, mismatch values, the number of unique values in the data, mean and mode, so we can kind of get a sense of what we might want to predict from this list. So scrolling down here, I also wanted to point out a couple of interesting things that Canvas does for you automatically. One of the things is if we look at gender here, you'll notice that there are just two unique values, male and female. So what Canvas will do is it will automatically assign a particular data type for that data, and in this case, it's binary. So Canvas tries to automate a lot of this for you, so you don't have to do a lot of the data cleanup. Other thing I wanted to mention is you'll notice there's a grayed out spot here for data source. This is because there was only one unique value in the data set. So if there's just one unique value, everything is the same. It's not really going to impact the accuracy or our model at all. So Canvas will just automatically remove that so that we can be assured that we get the best, most accurate prediction. So a lot of stuff that Canvas does to help you work with your data. Now that we have a sense of what this data is, it's time to identify the target that we want to predict. You could pick any one of these things. As I mentioned, we're going to focus on the survivability rate after 5 years. And to specify that column that we want to predict, we can go right up here to the pull-down menu and select the column. Again, in this case, it's survivability 5 years after diagnosis. And then Canvas does a handy value distribution. So we like to see a 50-50 split here so that we know that we have a good, meaningful, representative set of the data. That's something I just wanted to point out here. And another thing that Canvas automatically does is calculates the correlation to target. And we like to do kind of a gut check on this data to make sure that there isn't anything unexpected here. So we see a negative correlation between age of diagnosis and survivability. That roughly makes sense. But it's also interesting here that the year of diagnosis also seems to have a strong negative correlation. And that seems to me a little bit fishy. It wouldn't necessarily seem intuitive to me that this would have such an impact on the prediction. So we'll kind of explore that in the next part of the demo. Also wanted to call out that Canvas will generate the model type automatically for you based on your data set and on your use case. I typically always select the default model that Canvas provides, but if you want to change the model, again, business analysts can work with data science teams, you can do that. Also wanted to shift over to this nice grid view of your data. You can explore the histograms, and just wanted to point out one example. We can see that the age distribution is quite nice in this data set. It's a bell curve, and we have seemingly around later in life, we have more diagnosis. So really a lot to do here, but I just wanted to give you a sense of what Canvas can do. Also wanted to point out, we have this data visualizer capability, and I want to use the data visualizer to inspect a little bit more about that interesting correlation that we saw. We saw the negative correlation between the date of diagnosis and survivability, and that just doesn't seem right. So we're gonna go and explore this in the data visualizer view. So you can do many different things, scatter plots, bar charts. I'm going to go ahead and pull in a bar chart, and on the X and Y axis, I'm going to add the date of diagnosis here. You could keep this as is, but I'm gonna actually go ahead and change it and to do a count. So I can count the number of diagnoses in that particular here. Pointing out, by default, Canvas will pull in 100 rows from your data set. But since we have a very small data set, I'm going to go ahead and make that much bigger to 2,000. Again, you can have flexibility as an analyst to really understand the data better. So after you do a quick update, you can see what happens. And it's interesting here, we see that there seems to be a really sharp drop-off here between 2014 and 2017. And if you remember, our target that we want to predict is the survivability. So I'm going to go ahead and pull that in and group by the survivability. Again, we seem to have some data missing here. So this might help us explain that anomaly we saw earlier. And if you remember, this study was stopped in 2017. So we're doing a 5-year predictability study. So it makes sense that there actually wouldn't be data available here. So what Canvas will do is help you automatically remove that data and those rows from your machine learning model training, so that, again, you can help improve the accuracy of your model. So I'm going to go right up here, click the Remove Data button. Again, nice pull-down menu, select what column you want. I'm going to put year of diagnosis here. I'm going to say anything greater than the year 2014, because it's not going to be meaningful for our prediction. There's lots of different operations that come built in out of the box. And essentially what we're doing is we're creating transformations in a code recipe that Canvas will use during training so that we can get a really accurate prediction in the end. And you can add that to Canvas. One more thing I wanted to just go over here while we're talking about the data visualizer. I wanted to bring in one more thing which I think might be important for us when we think about the prediction, and that's the summary stage. So once your data visualizer is built, you can go back in, add, and bring in different data to explore. So I'm going to bring in the summary stage and going to group that by the summary stage as well. Again, we see something interesting here. It doesn't seem that there's a lot of data between 2000 and 2003. And that's because we actually didn't have data in our data set to know the summary stage at that point. So again, let's go back up into remove the rows and take out this data to support a really strong prediction. So same thing as we did before, go to the column, pick the year of diagnosis. This time I'm going to use the operator less than the year 2003. So again, I'm creating another code recipe or transformation that our model will use to ensure that it's accurate. So we could probably spend a lot more time looking at all the visualizations and data building that we can do in Canvas, but for now, we'll move on to actually building our model. But before we do that, wanted to call out the correlation now between the year of the diagnosis and the actual prediction. You can see this is not having quite that impact that we saw on the initial screen, just because we were able to do some good data cleanup. Okay, so now I'm going to, you'll see the nice button at the top. I mentioned there's 2 different ways you can build models in Canvas. I'm going to use the quick build model for the purpose of this demo, and it happens in 2 to 15 minutes. It's really quick. After the model is generated, you get this nice summary view. The accuracy of the model on top, 81% seems really good for this use case. Then you can see all the different model inputs that the model used to make the prediction. Interesting summary stage, age of diagnosis, tumor grade, gender, marital status, all these things seem to make sense. And it gives you ranked here on the order of importance that input had into the prediction. So what you can also, and this is also known as model explainability, and it helps build trust between data science teams and business analysts when you look at the data. And you can explore the visuals here too to see individual data points and how they impacted the prediction. So look at the nice scatter plot we have around age, and you can see how the age actually impacted the prediction. I thought it was interesting here that summary stage and age of diagnosis were actually more important in our prediction than something like tumor grade, which I didn't necessarily expect going in before working with the data and doing the model. But you can see, even though there are well-defined and localized many different tumor grades, the overall prediction is only really having about a 9% impact relative to the other model input. So something that was interesting to me as I was looking at the data. The final thing I'll say on this is marital status did pop up, and Seems intuitive, but it was nice to see in the model that if you have a partner who is looking out for you to make sure that you're taking your medication, going to the doctor, it really does help. And as a public health professional who was looking at this data, to me, it might inform things you could do around public health programs to talk about prevention and awareness and keeping up good communication with your loved ones. And this is the last part of the demo I wanted to dive into is going into the other tab called scoring. And this will allow you to show more advanced metrics and more advanced information about your model that business analysts can share with data science teams. I typically don't use this one every day, but I did want to call it out that all of this information is available. You can click on advanced metrics and see things like accuracy, precision, recall, all of the things that data science teams will want to dive into and work with, and maybe give some suggestions on different data types or other things to do to improve the model. And then finally with Canvas, you have the choice to do predictions at batch or individual predictions. Typically, me as a marketer, I like to look at the single predictions because I can perform a lot of what-if analysis. I can play around with the different input variables, change them, and see how that impacts the model prediction. And again, in the case of the public health, it might inform different policies that you would do to help with early prevention and detection of different diseases. So going into the summary stage, you can see I can change it from local to distant, and you can see based on the input parameters, the prediction does change in the end. So a lot of opportunity to perform the what-if analysis. So thank you for your attention during our whirlwind tour of Canvas. That takes us through the business analyst part of Canvas. We next have our ML engineering persona that focuses a lot on model deployment and scaling models into production. So to take you through how her organization has led this transformation, again, I will welcome Maria back to the stage.
Hi, everyone. So I started my journey at Thomson Reuters roughly a year ago. And the question that we had to ask was, how do we actually create an enterprise AI platform for our organization and for the needs that we have, where we have over 200 data scientists? And we made some choices along the way that I want to walk you through. So Thomson Reuters actually started AI a long time ago. It was in the 1990s when they created the first model, which was around search capabilities in plain English, and then more and more established NLP within our products, evolving continuously like the landscape of the AI that we use or the landscape of AI that's embedded within our products and within our workflow. And what have we seen since then? As I said, it started in the 1990s, but then naturally, the way that the evolution started with AI and the use of AI within the products, we also saw the same evolution within our business teams and how they wanted to use AI to be able to understand how our customers are responding to these products, how our financial forecasting should be done in a much better way. So we saw an increase in the use of AI across Thomson Reuters. But with that, we actually saw teams that have very different skill sets and they use very different tools. And more recently, we're seeing evolving regulatory requirements. I think Kimberly recently just touched on explainability, something that we see really coming up in the needs of our products and the needs of what we need to provide as a company. And naturally, we need to be able to reproduce our AI, and we need to be able to collaborate across the work that we do. But how do we establish that? How do we actually make sure that we create something that does everything that I said above, but in a reasonable way, and what do we actually need? So first of all, we need access to a secure environment. If we're dealing with data, we need to make sure that the access is secure. We need access to cloud because we know that that's where a lot of our resources are going to be, and we know that that's something that will allow us to scale. We need model governance, but not making data scientists have to pay a lot of, let's say, time to actually ensuring that governance is done. And then we need to be able to collaborate. So we need to create a platform that improves collaboration. So we chose SageMaker, and why did we choose SageMaker? We chose it, first of all, because it has a lot of services. The team just touched upon them, but like as we knew that we needed to evolve the way that we use AI, we had to create something that will evolve with us. We need the product that will continue to evolve and challenge itself. The second one, we knew that we wanted something that will allow us to do machine learning at scale And then we also knew that we wanted to be able to have a flexibility in the solutions that we would create. So SageMaker is great, but we knew that there were cases where we would have to customize. And I'm going to touch on some of them later on. And the final reason why we chose SageMaker is we have a great partnership with AWS. We find that we can rely on the resources, and we can also push some of our product needs back into the product and into the timelines for them. So what did we do? What did we do in terms of the AI platform? So we started the AI platform with thinking, how do we actually create something that will scale, whether we're looking at a data scientist that does something end-to-end. They bring the data in, they will create their models, they will deploy the models, they will monitor the models, but also thinking of completely different personas. So they just experiment. Someone else does the deployment. They don't do the monitoring. So we really needed to think, how do we create a platform that is really focusing on different personas and enabling to not kind of make some big assumptions about how they operate. So with that, we started thinking about the use case of the data scientist. So what's the first thing that they need to do? They need to bring data in. So our data is unfortunately in many different places. So the first thing we created was a capability that's called the data service that brings data in from Snowflake, from S3, from people bringing their own data, but kind of has like a governance layer on top of that that is needed for our enterprise. The second thing that then we needed to do is create an environment for experimentation. We felt that it was really important to make data scientists do data science, but not worry about how they procure access to cloud, how they set up their roles, how they set up permissions, how they set up collaboration with others. So we created a mechanism for them to use SageMaker and other AWS services with just a friendly UI, let's put it that way. Then we know that we wanted to be able to do registration of the models. Clearly, once someone has created the model and they know what they're going to do and move to production, we want our governance team to be able to understand what is the model about, what is that model going to do, is that model going to be fit for purpose, have they considered monitoring, have they considered bias, have they considered explainability. So we have a centralized registry, very much exploiting SageMaker registry under the hood that allows us to have both the capabilities of kind of managing our models, but at the same time, be able to have like the governance layer on top and a governance workflow that's very key for us and very key for Thomson Reuters. We then wanted to be able to create a deployment service. So again, you have a data scientist that they've created the model. But the reality is, if they want to deploy the model, especially if that data is not in AWS and it's in other places, they either have to kind of learn quite a lot around cloud, at least in the way that we operate, or they will then end up creating using their dev environments for kind of doing prod work, which is something that we don't really want to do. So we created a deployment service that utilizes SageMaker, where people can just pick the model, pick some parameters, and kind of deploy the model without thinking at all about what's happening under the hood. And then finally, we have like our ops capabilities. We know that we wanted to have model monitoring. We feel model monitoring is really important to us. As I said, a lot of our models are in production, so we want to make sure that the models are still performing the way that they need to. But then we also use so many of our models internally for our insights, so it's important to us to make sure we make the right decisions. And TR operates on trust. So for us, being able to ensure that our models are transparent and are fair is very important. So bias services, explainability services are key. So how do we do model monitoring? And I specifically love that service because it's such a mix of so many things under the hood. And it kind of scared people, but the reality is we were able to do that in a few months. We created model monitoring in a way that a user can pick up data from either Snowflake or S3. They can then specify the model that they want to be monitored, how often they want the model to be monitored, what parameters they need, how often they want to be notified. And then we were able to also make all of that happen in a cross-account structure. So because we have such a large scale of models, think that we have I don't know, we have like hundreds of models. You don't want to pull all the model monitoring together in a single account. That doesn't work. You do want to be able to orchestrate that from a central account, however. So key to our platform service is that idea that we have cross-account implementations that allow people to go from choose the account that they want everything to happen, the services to be deployed, while at the same time, for us, our central team, our central AI platform team, we can monitor all of that activity, we can orchestrate all of that activity. So from our central account, we deploy SageMaker into a target account. That target account, then we pull data from Snowflake or S3 into that target account, calculate a lot of our metrics on a model monitoring metrics, and then we push all of that results back into a centralized registry where we can visualize it or create alerts to our end users. And we also have the capability to not only use SageMaker model monitoring, but customize it as well. A lot of our models are NLP models that have summarization use cases where there aren't specific metrics at this moment in time available. So we are able, though, to customize the product and get the level of flexibility that we want. And this is how it looks like to an end user. So they go to a screen, they pick up the model, pick up the metrics, pick up the schedule, and then our monitoring service runs. And then after that, they see like the results of that model monitoring, as well as the specific values that they will get and get notified, as I said, if there is like a specific threshold. The thing that for me was key, and why I have here that the thing that's coming up next for us is the bias and explainability, is that we have seen how much that capability improves the way that we understand our models. It really helps us understand whether we need to retrain our model or whether we need to not retrain our model, how often we need to retrain our model. What do we need to do to make sure that our models are fair and our models are transparent? But then the architecture diagram that I showed you before, even though it might seem scary, the reality was, as I said, it was done in a few months. So then after we did the model monitoring, doing the data drift monitoring took 2 months. And now doing the bias one is taking 1.5. So we're really reusing a lot of the ideas that we have and a lot of the mechanisms of how we orchestrate our architecture. And then we're able to now continue to utilize the evolvement of the SageMaker services like Clarify in a way that it addresses the needs that we have. And then as we need to also customize that service, feed the feedback back into the AWS team that then accommodates and continues to evolve our product. The second thing that we're doing is migrating a lot of our legacy models into the SageMaker environment. And we found clever ways to do that without asking the data scientists to rewrite everything. And bear in mind, we have a lot of models that we have to do that for. And then finally, we're continuing to onboarding business units into our platform. We truly want to be a full, let's say, enterprise platform. So making sure that our services are adopted is really key. And that, I think, ends for me the journey that I would say we've had with AWS and SageMaker and what it has done for our environment. And I'll pass it back to Dennis.
Thank you so much, Maria. It was exciting to see the innovations that you do on SageMaker. We've been able to give you a quick tour of various features and functionalities in SageMaker. And so our customers are building and working and solving all of these use cases on top of SageMaker. And you can too. We've structured this presentation based on a persona, profile, right? You could be a machine learning data scientist, or you could be a business analyst or a machine learning ops engineer. And so we felt like it's fitting to finish today by giving you pointers to other sessions that are happening later in the week that are geared more towards these individual profiles. So we hope to see you take your ideas to production with SageMaker. Thank you so much.